In class yesterday we went over this identifying quadratic functions page. So I'm just going to quickly run back through it for those who needed a second take. On here it asks us to tell whether each function is quadratic and then explain. One of the things that we like to do is check the change. We've been checking the change to see if it was a constant rate of change to tell whether it was a line or not. Here we want to see if it's quadratic. So we'll do the same thing, and generally it's easiest to see from a table. So I'm going to put my values in table form. And then I'm going to check their change. From 0 to 1 is plus 1, from 1 to 2 is plus 1, and from 2 to 3 is plus 1. Over here, from 6 to 12 is plus 6, from 12 to 20 is plus 8, and from 20 to 30 is plus 10. I notice this is not a line because it doesn't have a constant rate of change. Its rate of change here is 10 over 1, its rate of change here is 8 over 1, and its rate of change here is 6 over 1. So I know that's not constant. But I do notice that all of these are different by 2. So if I was going from here to here, I'm adding 2. Here to here, I'm adding 2. Since it didn't have a first order rate of change, but it does have a second order, that pretty much guarantees me it's going to be a quadratic. Remember, quadratics have that little x square thing. Another way that I could check to see if it's going to be a quadratic is to put it in my calculator. So for those of you who are familiar with the calculator, clear out what's in there. We can go to Stat, Edit, and input our table. So 0, 1, 2, 3. Go over and put in our y values, 6, 12, 20, and 30. Once we have all of our information in the Stat section, we're going to go to Stat. We're going to go over and calculate. Now we're wanting to know if it is quadratic or not. So that would be option 5, where we have our quadratic regression. So we'll press 5, and we'll press enter through all of the steps, and it gives us an equation. So the equation it gave us was y equals 1x squared plus 5x plus 6. Now I want to check and make sure that that goes through all of those points. So I'm going to go to my y equals section, and I'm going to turn on the plot. That way I can see the points that I already have in there. And I'm going to type in my equation that the calculator says is the right one. And when I go to graph, I see it goes through the point that I can see. There are some more points on there. I'm going to zoom out a little bit. There are some more of the points. And I see that this quadratic equation goes through those points. It forms a parabola that goes through the points that are given. So yes, this one is a quadratic function. And it fits the ax squared plus bx plus c standard form of a quadratic equation. Well, look at this second one. It is 3x plus 2y equals 8. Most of you will realize right away that that's the standard form of a line, and it doesn't have an x squared term in it, so we're not going to have a parabola. So this is not quadratic. And we might mention that it's a standard form of a line. Remember, lines are not quadratic. Lines are straight, they have a constant rate of change, whereas quadratics are parabolas that have more of a U-shaped. Alright, on the next section, it asks us to use a table of values to graph each quadratic function. So if we were doing that by hand, we would be thinking about it in a function machine. So we have the negative 1/2 x squared, and we would pick some values to put in for x. Typically those values need to fit on our graph. They gave us a graph that goes from negative 5 to 5. We like to pick somewhere in between those two. Most people will pick negative 2, negative 1, 0, 1, and 2 because they're right there clustered around the center. So we're going to go ahead and pick those. And we could throw each one of those individually in by hand. So we have negative 2 squared, which would be 4. Half of that would be 2. And then we would have our negative. So negative 2. We could graph that, -2, -2. Our next point, if we put in -1, -1 squared is 1. Half of that would be 0.5, and with the minus sign we would have -0.5. If we throw in a 0, 0 squared is 0. Half of that is 0. And the opposite of that would still be 0. If we throw in a 1, 1 squared is 1, times a half, which would be 0.5, and then the negative, so this would be -0.5. And if we throw in a 2, 2 squared is 4, half of 4 is 2, and the opposite of that would be -2. So we could graph each one of those. -1, -0.5, 0, 0, 1, -0.5, 2, -2. We'll go ahead and connect those with a smooth curve. That's one way to get our quadratics graphed, or to come up with a table of values. What we could also do is we could enter these into the y equals section in our calculator. So for this one, that's what we're going to do. We're going to bring our calculator out, go to y equals. I'm going to turn the plot off since we're on a different problem. Go up to the plot and hit enter, and that'll take it off. And then I'm going to clear out this equation and put the equation we're working with now. 2x squared minus 3. Make sure you use the minus and not the negative sign. And if we wanted to see what it looked like, we could hit graph. Remember I changed my window a while ago, so I'm going to change my window back. I'm going to hit zoom and go to standard window. There we go. And now to get the table, I'm going to hit second and the graph button. And here's my table. Now I'm going to use the same x values that I did on the last one. And I'm just going to get those from my calculator this time. And of course, once I have those points, I can graph them. So -2, 5, -1, -1, 0, -3, 1, -1, and 2, 5. This parabola is kind of a tall, skinny parabola. And one side didn't curve very well. So we'll see if we can straighten that up a little bit. A little closer. Alright, so that's a couple of ways to graph each quadratic. Down below this, it wants us to tell whether the graph of each quadratic function opens upward or downward. Remember on our notes, we said if it was in our standard form, which means our y is on a side by itself where it's positive, and all the other stuff, the x's, the numbers, were on the right side, and our x squared term was positive, then it would be facing upward. And if it's negative, it would be facing downward. So here we have a negative 3x squared. So the x squared term is negative, which means it's going to be opening downwards. And if we wanted to check to make sure that that was correct, we could put it in our calculator. Negative 3x squared plus 5. We'll look at the graph, and sure enough, it does open downward. This next one is not quite in the form we need it in. Remember, we need to get the y on a side by itself where it's positive, and everything else should be on the other side. Then we can read our x squared term. So I'm going to move this x squared over by adding x squared to both sides. And I have y equals x squared plus 8. Notice now my x squared is positive, which means I would expect it to be facing upward. We could check that in our calculator if we wanted to, just to make sure it was correct. So we put in x squared plus 8. Graph. And we can barely see it, but it is opening upward. For the last section, they're asking us to do multiple things. One of the things they're asking us to do is identify the vertex. Then they're asking us to give the maximum and minimum range, or value of the function. So we'll need to know whether it is a max or min, and then give the value. And then they're asking us to find the domain and range. So the vertex on this one is the turnaround point. It's also our highest point, so it's going to be our maximum. It's at -2, 6. So that's our vertex point. It is a maximum because it is the highest point. And our x value was -2 when our y value was 6. It wants to know the value, so we're going to say the value is 6. And then for our domain and range. For domain, this parabola is going to extend and get wider as it goes, and it's going to go forever and ever and ever. So there's really no starting spot over on the left side or ending spot on the right side. So we could put that it goes from -infinity to infinity, or we could just write that as all real numbers. Our range, however, is going to start up here at 6, and it's going to continue to go down forever. So for our range, we're going to put that y is less than 6. And then when we look specifically at 6, since it's a closed-in circle, we're also going to put an equal to, because that point is included in our answer. For the next one, if I'm looking at it, its vertex appears to be at 3, -3. It's also the lowest point on that parabola, so it is a minimum. They ask us to tell what the value of that was, so when the x was 3, its y was equal to -3, which would be our value. And then last but not least, we're going to do our domain and range again. Same argument holds true on the domain. This is going to continue to widen forever, so our x is just going to keep growing in both directions, which means our x could go from -infinity to +infinity. Or we could write all real numbers, because we could put in any x value we wanted to, and we'll be able to get out a y value. Our range looks like the lowest spot is going to be at -3, and then it's going to continue to grow in that direction forever. So all of those values are greater than this -3. So for our range, we're going to put y is greater than -3. And then when we look at that point, it is a closed circle, which means we get an equal to. On a side note, if you have this page and you're looking at these parabolas, if I was to draw the axis of symmetry, notice it is at x equals -2, which happens to be the same as our x value, because remember our vertex is on our axis of symmetry. Same thing over here. If I was to draw my axis of symmetry in, it's at x equals 3, which also happens to be my x value over here.